Hello everyone, I'm Liu Kai. This is my project title, Machine Learning-Based Performance Model for Network-on-Chip Architectures. So this part is about the project background. So as the on-chip multiprocessors and multiprocessor system on chip are now meeting the growing demand for high performance in processing large-scale data and applications. The traffic and frequency in network-on-chip architectures such as CMPS and SoCs has increased accordingly. NOC performance parameters such as latency, power, and throughput have a direct impact on the overall performance of the architecture and execution time of the application. Along with the increase in size of the NOC architecture, some simulation software has become slower in use. Because of its strong generalization ability and self-learning capability, machine learning can solve some problems in data analysis that cannot be solved manually, and is widely used in the fields of uh, biology and engineering in order to measure the performance parameters of NLC more quickly, and currently it becomes more important to design a machine learning model to measure its parameters. Here is the architecture of the NLC. As shown in the figure, the architecture of the basic NLC is shown. NLC applies micro-network communication measures to the chip, with each core acting as an independent unit and the IP cores connected to a specific router via a network interface. The communication between IP cores is converted to router-to-router communication. The traditional NLC architecture mainly consists of router nodes, IP cores, a resource network interface, and channels. So here is about the research problem. This is my benchmark paper. In this paper, machine learning model is machined to predict the latency and hop cost of NLC. However, in the prediction of the actual performance parameters, it has have to predict the throughput of the NLC. Along in this paper, only one machine learning algorithm is mentioned. In practice, I have to consider more kinds of algorithms for compression. So here is about the project aims and objectives. The aim of this project is to design a machine learning model to predict the performance parameters of NLC. The objective is first is to build the NLC architecture in the simulator. Number two is design machine learning model and choose the right algorithms. Number three is predict performance parameters such as NLC latency and throughput. The project scope the scope of this study is certain on the measurement of performance parameters of NLC in 2D mesh or torus topology with different injection rates. And the safety ground, number one is the NLC simulator offers powerful features. Number two, diverse machine learning algorithms. So here is about the Gantt chart. In these systems, task one is understanding the project background and project purpose and writing the chapter one. Task two is find the relevant lecture and study the lecture and write a lecture review. And task three is based on what we have learned. I have proposed the knowledge related to this project and the theory needs for this time to propose a prototype of the project design. And for the next systems, Task one is to write the methodology, and task two is run this project and get the results. And task three, I need to write the final report. So this part is about the lecture review. So I searched several papers, but in these papers, most of the papers have mainly focused on the range latency of NLC when predicting its performance parameters. So in this paper, uh, I need to add in the prediction of its throughput, and I will provide a more comprehensive understanding of the performance of NLC. So for the lecture review, I divided it four parts. Uh, the first is about the topology of the NLC. I need to introduce the mesh and torus. And for the NLC simulators, there are many simulators. So I choose two, sim and NoxSim. And for the Queen serial and machine learning model. Uh, this is about the machine learning model of the lectures. In this paper, uh, in the first paper, he used the SVR algorithm, and but he set fewer parameters. Uh, but in the second paper, he analyzed the NOC and the 3D structure. But in this project, I will analyze the NOC and the 2D structure like mesh and torus. And in this paper, only one structure model of NOC is considered. For the third paper, he compared against the other model. This model reduced its mission error by up to 89% on range, but there is no routine logarithm of NOCs explored, and the impact of the traffic patterns is not explored. And for the fourth paper, in this paper, the framework showed an approximate prediction error of 5% to 8%, and the overall minimum speed up of uh, uh, 1,500 to 2,000. But in this paper, only a single routing algorithm was selected. And there is also only one setting for the buffer size. So here is the timeline of the lecture. So this part is about the methodology. So in this project, I need to write a Python script to run this simulators and get the data set. And I need to divide dataset two parts. One is the training dataset, and one is the testing dataset. So the training dataset will to the machine learning model, and I use the testing dataset to train the um, machine learning model, and finally I will get the predicted results, and I will compare the predicted results with the simulators to analyze. So here is the main purpose is shown in the previous future. So here is about the parameters set in the simulators. So I need to set several parameters like topology type, network size, traffic pattern, number of virtual channels, buffer size, packet size, routing algorithm, sample period, and injection rate. So here is about the pre-processing of the data. So when I get the dataset from the simulators, I need to pre-processing. So here is maybe there is some missing values. So I need to take the surrounding range for the missing values and to complete the missing values. And when I complete the missing values, I will divide it 75% of data will be the training data set, and uh, 20 25% of data will be the testing data set. Here is about the machine learning. In this project, I will compare the three machine learning algorithm. Number one is the SVR, number two is the random forest RF, and number three is the artificial neural networks. And when I get the data, I will do the pre-processing and use the three uh, different machine learning model and evaluation and compression and choose the best model. So there is about how to analyze the results uh, between the simulator and the machine learning model. Uh, Here is some parameters. Number one is the MAE. Number two is the MSE. Number s- uh, number three is the coefficient of determination, and number four is the speed. The above values are compared among the three models so that a more appreciate a prediction model can be selected. So here is about how I talk to my supervisor. So this is all my report. Thank you for your listening.